Hi, this is Math 1350, and this video is going to be over section 1.6, transformation of functions. And we're going to start off briefly talking about parent functions, and then we'll get into the different transformations of these parent functions. So parent functions is basically the most basic graph of each particular type of graph. So for example, linear functions. The parent function is f of x equals x or y equals x. So we can plug that in. Actually, I'm going to do the function notation. And we see it's just a straight line. And some common points it goes through is points, well, that's 5, 5 by 1, 1, and point negative 1, 1. Okay, so these are points on the graph. And we're going to see that these points are going to be very common for a lot of these functions. So 1, 1, negative 1, negative 1, and then another one is 0, 0. Okay. All these are on the graph. All these are very common, and all these can be used to see what happens in the transformations of these. The next one is the power functions. So first one, there's two of them, or two of the basic ones, x squared, y equals x squared. Okay, we can see negative 1 is not on the graph. The point that is negative 1, 1. So that's another common point, right? So it's either negative 1, 1 or negative 1, negative 1, depending on the type of graph, right? And so this also goes through 0, 0 and 1, 1, and we can see it has that U-shaped curve to it. If we make this x cubed, right, this one goes through negative 1, 1, it goes through 0, 0 and 1, 1. Has a snake-like curve to it. Right. And then we have, skip down to the last one real quick, absolute value of x. And we see it goes through negative 1, 1, 0, 0, and 1, 1. Okay. And so this is more of a piecewise function with two linear functions pieced together, and y equals x and y equals negative x. Alright, and then we have a radical function, so square root of x. You can see it goes through 0, 0, kind of the end point there, and 1, 1. And it's just a radical function, so it just goes up. And we can look at a cube root, which is similar to a radical function, so 1/3, and it's going to go through points negative 1, 0, 0, and 1, 1. I didn't label that one anymore. Right. Then we can look at 1 over x, and we can see it's going through point negative 1, and it's just in that third quadrant, and point 1, 1, and it's in that first quadrant. But it doesn't go through 0, 0. It's one of the few because there's that y equals 0 asymptote and x equals 0 asymptote at the origin. We can actually square this one too, and we have something that's now a little bit different. Still pretty much the same graph on the right, but on the left, instead of it being in the third quadrant, it's in the first quadrant. It goes through point negative 1, 1. Right. So those are common things about these types of graphs, and we're going to see what happens to the points as we go through these shifts. All right, and transformations. All right, so let's start with the first transformation. When we add to the function or add subtract to the function, right, it's going to shift it up or it's going to shift it down. So let's just start with x, and then f of x, let's call it something different, g of x equals x plus 5. And then I'm going to insert a table. and I want f of x and g of x. Let me get back to my axis. All right. And what we see here is, let me switch color on this so we can see it better. Do blue. Y equals x plus 5 is always higher than y equals x, and it's always 5 units higher. So if we look at, x equals 1, for instance, it's 1 for y equals x, it's 6 for y equals x plus 5. So the 0.11 jumped to 1/6, went up 5. Okay, and if we look at the other points, 0 and -1, 0 went to 5, -1 went to 4. Again, it's all the same vertical jump. There should be, I don't know why there isn't, but there should be a axis on this. I gotta connect this. 1 second. Should be around here. And this should be at 5. Okay, and this is the vertical difference of 5 everywhere along this graph. All right, if we look at x squared minus 4, we see this is, let's do that in the second one. And we'll just keep x squared up here. Okay. So we see the red one is the original function, and then the blue one is our shifted function. And so this one, instead of it being at the y's being at 1, 0, and 1 for the based on those x's, they get shifted down 3. So at 1, that point goes, that 1, 1 point goes to 1, -3. 0, 0 point goes to 0, -4. And the -1 point goes to -1, -3. So with this graph going through this, all these points are shifted down 4 units. Right, so this is vertical shift up 5 units, vertical shift down 4 units. So we can look at some more with shifts. But before we do this, we're going to basically look at what we have and say what's going to happen. So x cubed graph, we're going to have that graph be shifted up 2 units. 1 over x minus 6, this is shifted down 6 units. And the absolute value of x plus 2/3 shifted up 2/3 units. And you can draw the graphs on here. I'm just going to put them on Desmos and actually draw them. And so the first one, x cubed plus 2. So we'll switch this to x cubed. And x cubed plus 2. And we can see this point goes from 0, 0 to 0, 2. So it's shifted up 2 units. And this point goes from -1 to up 2 units. -1, 1. Threw me off that point was the original point. And then 1, 1 goes to point, if I can click on it. Well, 1, 3, I'll just say it. Right. And so we can see with these, 1, 3, 0, 2, -1, 1. Okay, no, actually, take away the labels on these so it's not as cluttered. I still have the points there though. Alright, so pause it if you need to graph it. I'm going to move on to the next one though. 1 divided by x minus, oh, let me do the second one as the transformation. 1 divided by x minus 6. And so zoom out a little bit here. Right, key thing with this one is our horizontal asymptote. We have a horizontal asymptote at y equals 0. Okay, this red line doesn't go past the y equals 0 marker. Same with the red line on the left side or the right side. Okay, the blue graph, it's shifted down, and so that horizontal asymptote also ends up down at y equals -6. So if we were to graph those two, put them down here. So y equals 0. I'll make it an asymptote. And y equals -6. Also make that an asymptote. Okay. We can see that asymptote got shifted down 6 units. And that's the key thing with rational graphs is you want to be able to show, or you want to see what happens with the asymptote. Right, so I'm going to, it's getting kind of messy on the Desmos with everything, so I'm going to graph it real quick on here. So again, the original asymptote is here and here. Original graph looks like this. And then there's at -6, the asymptote has moved down. And so now the graph looks like this. I don't know why I will make that dotted. And all those points move down as well. 1, 1 goes to 1, -5, and -1, 1 goes to 1, -1, -1 goes to -1, -7. Right, so those points move down. Right, so now the next one, absolute value of x. How do we do that? And then we're adding 2/3 to this. Right. And so this just shifts the absolute value graph up 2/3. So 1, 1 goes, you know what, I'm gonna see if I can enlarge this just enough. Alright. 1, 1 goes to 1.67, which is 1 plus 2/3. 0, 0 goes to 0, 2/3. -1, 1 goes to -1, 1 plus 2/3. So everything shifted 2/3 up. Right. The next shift is the horizontal shift. Now, this isn't applied to the function. The adjustment, the adding or subtracting, gets applied to just the x, and so any operations on the x happens to take into account this transformation as well. See, the original ones, when we add or subtract to the function, it just takes the final value of what we had for the function and either adds to it or subtracts from it. This one adds or subtracts first from the x, then applies the function and the operations in the function. Okay, and it's kind of goes against intuition here. If we are subtracting from x, we actually shift it to the right. So subtraction causes a shift right, and addition causes a shift left. So let's do a couple examples. X minus 4 squared. So let's look at x squared and x minus 4. Sorry, I thought I was going to go over everything. Oh, it's still not doing that. X minus 4 squared. Okay. And so we can see this x minus 4 squared, it's shifted to the right 4 units. So 0, 0 goes to 4, 0. And so, again, you can graph it on here, but this is shifted to the right. Okay. So what happens with the rest? If it's a cubic, it's going to be shifted, adding 2 to it, shifted left 2 units. If it's the absolute value graph, it's going to be shifted left 3 units. And this g of x 1 over x minus 6, I'm going to do that separately because it's going to be a little bit different. Or I shouldn't say it's a little bit different, but it's going to be a little bit interesting. So I'm going to do that separately. Alright, so with each of these, we can take some of these points. The first one, 0, 0, gets shifted to 4, 0. 1, 1 got shifted to yeah, 1, 9. So oh, hold on a second. We're doing the horizontal shifts, so we're going to have to do this a little bit different. 1, 1 gets shifted to 1, 5. I'm sorry, 5, 1. Alright, so 1, 1 gets shifted to 5, 1. And then negative 1, 1 gets shifted to, and you add 4 again, 3, 1. Right. For x plus 2 cubed, the same points. Zero, 0 gets shifted to negative 2, 0. 1, 1 gets shifted to negative 1, 1. And negative 1, 1 gets shifted to negative 3, 1. Okay, so the changes are only on the x for this. So 3 x plus 2, make that cubed. And so we see these points. 1, 1 goes to negative 1, negative 1. 0, 0 goes to negative 2, 0. And negative 1, negative 1, that should be negative 1, goes to negative 3. I'm almost on it to negative 1. I'm just a little bit off from, there we go, just had it. -3 to -1. And absolute value 0, 0 will go to -3, 0. 1, 1 goes to -2, 1. And -1, 1 goes to -4, 1. So x plus 3. And so we can see that happens here. -3, 0. So that's where that went. -2, 1. So that's where the 1, 1 point went. And -4, 1. That's where the -1, 1 point went. Alright, so let's do the next one. 1 over x. And then 1 over x minus 6. Alright, and so here's the thing that why I wanted to wait on this one. I'm gonna turn off some of these points. It's starting to be kind of chaotic. Right. The graph shifts to the right. You know, it's -6, so it's going to be a shift to the right 6 units. And the key thing here is the asymptote, the y = 0 asymptote shifts to, I'm sorry, not y. X = 0 asymptote shifts to x = -6. And so we can see, you know, that shift here happens. You know, notice the horizontal asymptote stays the same, right? But 0.11 shifts to 7.1. 0.11 -1 shifts all the way to -5 or +5 -1. So again, these points shift 6 as well, but you also got to look at the asymptote and how that shifts. Alright, so next thing is reflections on here. Reflections, if the negatives apply to the whole entire function, it reflects it across the x-axis. So, and the reason why is if you have y = f of x, and then you say, well, you're going to have a negative sign on the f of x, then that means that the y is now negative, right? And so, you know, a point here that's, let's say, x, y, is now x negative y. Right. And the other side, if the x is negative, then it flips across the x or the y-axis. So the point xy is now negative x y. Okay, so that's what negatives do. And this one can be kind of tricky because if we see something like a horizontal shift and then x is negative, we have to flip the shift to it to do it. So negative x minus 4 squared. We're going to start with our x squared, and then we're going to do negative x minus 4 squared, and we see there's two things happening here. One is it's shifted 4 units to the right. The other one is it's reflected across x-axis. So the point 0, 0, we shift it first to the right, so it's 4, 0. And then when you reflect a point on the x-axis, it stays on the x-axis. So 0, 0 goes to 4, 0. The point 1, 1 gets shifted 4, so we can delete these. So we can say it goes to 5, 1. So I'm going to put in that intermediate point. I'm going to do a couple intermediate points here to see the shifts. So we just do 0. So it's shifted 5 units, or 4 units over to 5, 1. And then it's reflected across, and so it's at 5, negative 1. So 1, 1 goes to 5, 1, which goes to 5, negative 1. And then negative 1, 1 goes to 3, 1. That's your intermediate point. And then it gets flipped over to 3, negative 1. Okay. So now the next one, negative x plus 2 cubed. I'm going to show this first. Notice the negatives on the inside with this, x plus 2 cubed. And don't worry about this point right here. I'm going to be moving it once I show a couple of shifts with this. But what we have here, we have a flip across the y-axis. Which causes it to look like it's going the opposite direction. And then we have a shift, horizontal shift. Now, the way this works, we've taken the shift on and the reflection at the same time. You know, a point 0, 0, instead of it being shifted when it's a plus sign 2 units to the negative side, it's more shifted 2 units to the other side because of that reflection. Or you can think of it as it went 2 units to the negative side, then got reflected across the 2, 0. And so 0, 0 goes to 2, 0. Point 1, 1 on the red line goes 2 units to the positive side and gets reflected onto 1, 1 again. Okay, and so point 1, 1 goes, I'm going to do this in 2 steps here, negative 1, 1, and then back to 1, 1. Okay, and then negative 1, negative 1 goes 2 units to the left, and then gets, so it goes from negative 1 to negative 3 (-1), and then gets shifted all the way to the other side at 3, (-1). Right, and so that's how we get those 3 points for the blue, and then you have your graph, or you can make the graph. Right. The absolute value of (-x plus 3, again we have a horizontal shift and a reflection across y axis. Right, so with the plus 3 you should get shifted left, so it goes to -3, 0, and then the reflection across the y-axis takes it back to 3, 0. If you go 1, 1, it goes 3 units to the left, so -2, 1, and then goes to +2, 1, and then for -1, 1 goes to -1, 1, and -3, 1, and then 2, 3, 1. Did I add that? Oh, I'm adding 3. Sorry, I added 2. So -4, 1, and then goes to 4, 1. I think I was adding 2 because I added 2 last time, in the last problem. Alright, so let's do this. Absolute value of x and then absolute value of x plus, I'm sorry, (-x plus 3. Right, so 0, 0, I'm going to get rid of this right now. 0, 0 goes to 3, 0. 1, 1 has went to now 4, 1. I'm sorry, 2, 1. 1, 1 went to 2, 1. Okay, and now it looks like 1, 1 went to 4, 1, but remember it's the shifted the other way, then reflected across. And -1, -1, that went to 4, 1. So they kind of ended up on the other side. The symmetry of this kind of flips those 2 points. Alright, so now let's look at (-1/x minus 6. One thing I want to do with this though is I want to factor out a negative. Or not factor out, distribute the negative. It's already kind of factored out. Alright, so I'll have (-1/6 plus 6. Okay, helps see it a little bit better. There's a reflection. And the question is it over the x or is it over the y? And then there's a shift up 6 units. Right, so let's answer that question if it's over the x or over the y. And so we're going to go 1/x, and we're going to go (-1/x plus 6. Okay. So let's look at point 1, 1. We have a reflection, and then we have a vertical shift. Okay, the vertical shift of the asymptotes is the easy part because asymptotes don't get changed by reflections, but this y = 0 just goes up 6. Okay, but we see that these lines, the red lines, don't mirror, aren't just shifted up, they're reflected, right? And so 1, 1 and (-1, 1, we have to figure out what's it doing. Okay, And both of these, if you look at 1, 1, it goes to, here I'll put in, what did I just do? There we go. 1, 1, put an intermediate point here, gets reflected to negative 1, 1. That's your intermediate point. And then it's that point is shifted up 6. 1, 2, 3, 4, 5, 6. Okay. Negative 1, negative 1. Okay, which is here. That's getting shifted across the y-axis to 1, negative 1. So that's your intermediate point. And then that point gets shifted up 6. 1, 2, 3, 4, 5, 6. So in both of these cases, the reflection's over the y-axis. Okay. All right, so vertical stretching, vertical shrinking. Stretching basically multiplies the graph and increases the size of it. Shrinking reduces the size. Okay, so we'll put in these graphs. So and there's going to be a couple adjustments to these graphs, not just one. So x squared, and then negative 2 x minus 4 squared. And we can see the shifts on these. First one is it's shifted, horizontal shift. 4 units to the right. And then it's magnified by a factor of 2, doubled in size basically, and then it's reflected over x-axis. And so 0.11, that point goes 4 units to the right, so it goes to 1, 5. Then it gets doubled, also reflected, so it goes to 1, negative 10. And so I'm sorry, I added to the wrong one. Didn't make sense once I looked at the graph. It's horizontal shift, so 5, 1. And then it gets doubled in size, so it goes to 5, negative 2. And so 5, negative 2 is this point here. Okay, so that's what 1, 1 went to. 0, 0 just did the shift of 4 units. It didn't change in magnitude, because when you multiply 0 by any number, it's still 0. So that just went to 4, 0. And then negative 1, negative 1. I'm sorry, negative 1, positive 1 goes to 3, positive 1, and then when it's multiplied by negative 2, it goes to 3, negative 2. And so that's this point down here. The next one, it's a cubic function. And we'll have a 1/2 on front and a negative x in front of that, and plus 2. And again, this is cube. So it's flipped across y-axis. It's shifted horizontally by 2. And and it's reduced by a factor of 2. Right. So 0.11. We got a shift of 2, and then it's reflected, and then it's reduced. So the shift of 2, let me see where this went here. Oh, it's reflected across the y-axis, and then it's reduced. So went 2 units to the left, then reflected across, then reduced down. Okay, and so it goes from 1, 1 to -1, 1, which then flips it back across to 1, 1 again, and then it's reduced down to 1/1, 1/2. This is where that point is. Okay, 0, again, the shift is the only thing. It gets shifted 2 units to the left, so it just goes to 2, 0. I'm sorry, to the right. Doesn't get affected by the factor reduce or the flip. And then the -1, -1, it goes, get rid of all those. -1, -1 goes to -3, -1. Goes to 3, -1. And then gets reduced to 3, -1/2. There. Alright. Horizontal shrinking and stretching. This kind of goes opposite. When you multiply the x by a number greater than 1, it actually causes it to kind of reduce down and shrink down and compress, right? Whereas if it's multiplied by a number less than 1 or a fraction, it actually causes it to increase. Okay, now this g of x equals -1/5x minus 6, that's going to be slightly interesting, so we're going to look at that directly. We're going to start with the first one. So this is the absolute value of x being multiplied by 2. So that reduces it or compresses it. There's a horizontal shift of 3 and a flip over y-axis. So absolute value of x, and then absolute value of x shifted to x plus 3. Okay. Now, of course, the easy point here is 0, 0. You notice it's, you're adding 3, but it's not just getting shifted to 3. It is being reduced horizontally, so it goes to 1.5. The only thing that doesn't affect it, well, actually, it does affect it. Notice it got shifted the other direction. All right, so we can think of it as being shifted from 0, 0, shifted to 3, 0, and then reduced down to 1.50. Or we can think of it as a shift to negative 3, 0, since we're adding to the x, and then flipping it to 3, 0, and then reducing it down to 1.50. These 1, 1. Again, if it's shifted 3 units, 1, 2, 3. All right, so shifted 3 units to the left, so we're at 1, 2, 3, negative 2, 1. And then we multiply across the y-axis, so it goes to 2, 1. And then reduce down in half, so it goes to 1, 0, 1, 1. And so it ends up right back at where it started. And then negative 1, negative 1 goes to negative 4, 1, goes to 4, 1, goes to 2, 1, which is going to be this point here. Okay. So now the next one, so we'll look at this 1 over x and compare it to, before I put this in, I'm going to distribute that negative sign. One divided by 5x plus 6. All right. Now we're adding 6, so we see the asymptote, the vertical asymptote, the horizontal asymptote shifts up 6 units. All right, so the asymptote y equals 0 goes to y equals 6. Okay. It's getting the points like 1, 1 that's a little bit tougher in this one. The 1 over 5. Right, we're multiplying the x by 5. So don't think of this as being 1 over 5 as the fraction. Think of it as just the x is being multiplied by 5. So what happens when we multiply the 5 by x? That's when we end up reducing it down. Right? Or reducing it down. So a couple points here. We start with 1, 1. Then it goes to 0.2 since we reduced it down by 5. And then we're reflecting it. So then it goes to a negative 0.2. And then we're multiplying this by, adding 6 to it, so it goes up to 7. And we get to a point. Right, so I'm going to write this down. The 5 being multiplied to the x reduces this down to 0.2. 1. The negative sign here makes it negative 0.2, 1. Keep forgetting to put the negative sign in. And then we get negative 0.2, 7. Yep. Alright, so same process with the next one, negative 1, negative 1. Goes to negative 0.2, negative 1. Goes to 0.2, negative 1. And then you add 6 to it, so it's 0.2, 5. And so that's where that point is on the blue graph. Alright, so it's you have to remember to, you know, take away the parentheses to help do this. There's different things going on too. We have the flip over y-axis, the horizontal shrink, and then the increase, vertical increase, vertical stretch, or no, vertical shift of 6 units. Alright, so we're going to look at these and just kind of go through what's supposed to happen and then graph it real quick. This video I think is getting kind of long, so I don't want to be on. Oh yeah, it's almost an hour. Okay, yeah, we're almost done though. Alright, so f of x, this is, you know, we can see a vertical shift, 5 units. We can see a horizontal stretch by a factor of 2, and a reflection over y-axis. So it's got shifted up, reflected, so it's going down now, and it's not as steep, so it's been compressed. All right, next one. We'll take this from an x squared to x minus 1 squared plus 4/3. And so we have a horizontal shift of 1 unit to the right, vertical shift of 4/3 up, and it's being multiplied by a factor of 2, so it's getting stretched out, so it's getting more steeper. So multiplied by a factor of 2. Okay, next one, it's horizontal shift to left, vertical shift of 2 up, and then multiplying by 1/3 on here, so it's vertical shrink by 3, factor of 3. So it's shrunken down some. Let's move this over. Get rid of that point. All right, and so the next one, -3 divided by x plus 2 minus 6. Oh, I think I had to do this to 1 over x. Alright, so vertical shift by -6, so 6 down. Horizontal shift of 2 to the left. Right. Notice that vertical asymptote is shifted to the left, and it's shifted about at, well, yeah, about -2 to the left. And then the horizontal asymptote, which would have been at y equals 0, is shifted down as well, -6. Yep, that's about -6. Alright. And then it's reflected as well. Reflection over y-axis. Okay. And the last one, absolute value of 2x minus 3. And so we see it's shifted to the right, but notice it's not shifted 3 to the right. This point only goes to 1.5, so it's shifted 1.5 units to the right, and that's because it's also compressed horizontally by a factor of 2. So shifted 3 units to the right, but compressed by a factor of 2, the point moves 1.5 over. And then it's reflected over x-axis. Alright, so that is it for this section. In the next section, we'll look at combining functions. See you then.